You guys remember these peanuts? How cute are they? Every time I'm in a bad mood, I just look at AJ smile. He lost his other tooth now, so it happened the night before his school started, and they sent us the smile, and he looks like a chipmunk because his front teeth are there, but the side teeth aren't there anymore. It was pretty great, and his new goal is a man bun on the top of his head, so he has like this like weird mohawks thing going on, and it's like really long but not long enough, and it's in that awkward stage, which is pretty funny. So you guys didn't know this, but you were actually part of an experiment when you guys answered the question about Nate and AJ. So it turns out that the afternoon classes and the morning classes had there was a slight difference on how I approached the which one is which I kind of cheated, but I didn't tell you guys about it. Because if I had told you guys about it, it would totally not have worked. Fair enough? So here's the deal. When you guys were presented with this photo last time, it was just in a Word document, and the title of the Word document changed. Okay? So for 7th period, the title of the Word document was Nate and AJ. For 8th period, the title of the Word document was AJ and Nate. And for the 2 morning classes combined, because you guys are kind of similar in size, combined, the title of the Word document was The Boys. Now, you guys didn't know this at the time, did you? Mm-mm. No, because I'm sneaky like that. Sneaky. But knowing this, can you guys tell me what was I trying to decide here?
If the title had an influence on what we chose.
Yeah. Like, for instance, since the actual order in the picture was Nate and then AJ, it's possible that more kids would get it right here than at the other two. You know what I'm saying? And then it was like, well, this one could be like I led people the wrong direction. So then we had this kind of concept of a control group, which we'll talk about control groups a whole lot more in Unit 3. Okay? So the goal in Unit 2, it's not really a chapter because we don't use a textbook. The goal in Unit 2 is to really start looking at, hey, when I have 2 different variables, how do I decide if 2 variables are actually related to each other? Because there's like some noisiness from statistics not being perfect and in dealing with variability amongst different groups. Does this make sense so far? So a lot of times when we look at relationships amongst groups, we might start looking at the types of variables we have. So in science, you guys learned about like independent and dependent variables, right? What are the variables we had at play here? Because there was kind of 2 things going on here. The first was me manipulating you guys, right? And it was essentially the title of the document that you guys got to look at. What was the other one? The one that you guys actually cared about more. Were you right or not? You guys get what I'm saying? Okay, so in statistics, we call the independent variable the explanatory variable. It's the one that is explaining. And in this case, are you guys with me that the title of that document, one of these 3 things, that was my explanatory variable. And I was trying to use that to explain the different ways our response variable, so our dependent variable is our response variable, and that is, I was trying to use the different title cards to explain why sometimes more people got it right or wrong. What do you guys think so far? So you guys are somewhere, all of your responses are somewhere in this column. And in fact, you are either one of the 13 or one of the 9, and you are definitely one of the 22. And so you guys know, did you get it right or wrong? You don't even need to broadcast it. It's fine. If you really want to, you can. But like in general, we can kind of summarize these things in this kind of table. This is called a two-way table, in that there are 2 ways we are identifying people, right? First of all, which group were you in? And then also, did you get it correct or incorrect? How are we feeling so far? All right. So in this two-way table, we have the actual data. That's that set of numbers. Okay? The totals are what we call the margins. And believe it or not, those totals are the summary of each group. All right, so, guys, what are some good things that we can see from this table? Like, what are some of the pros of looking at this table? And then we're going to look at some of the cons of this table. What are some ways this table tells us information? Yeah.
It's like easy to like understand it. I feel like and like look and just see like how it was different.
I'm going to say it's easy to understand. I'm going to push back a little bit on the see how they are different. For example, this 13 and this 13 mean 2 very different things because of the group sizes. It doesn't, so what I would call as one of the cons is group size, when I'm just going to put a question mark. In that it's really kind of hard to tell from the group size what's going on. Because now, if you had a two-way table where all the groups were the same size, I think that would be very, very meaningful on its own. Okay. We could make this out of relative frequencies. Like we could put percents in instead. For sure. We have to be a little bit cautious of how we do that. For sure. But what do you guys think so far? I love two-way tables. We're going to... You are nowhere near done talking about two-way tables. We'll talk about them in Unit 4. We'll talk about them in Unit 8. And possibly Unit 7. No, 6. 6. They're going to come back a lot because they're very, very useful. Everybody good? All right. So we're going to learn 3 different types of graphs today. The first one's called a double bar graph. So typically when we make graphs, typically, not always, definitely not always, we put the explanatory variable on the x-axis. So my title was either Nate then AJ, or AJ then Nate, or the boys. And let's see. I said proportion. Let's go ahead and say frequency of response. So, sorry I didn't do like much explaining, but my experience is kids usually understand how to draw the graph. Some key components, notice that I have both axes very descriptively labeled, and then I have a little key as to which bar is which. Notice that the correct bar is always on the left and the incorrect bar is always on the right. What I care about there is consistency, okay? But it's going to be really hard to compare if sometimes I had red first and then blue, and then sometimes blue first and then red. Okay, so you just want to make sure your graph is communicating everything it needs to communicate. And when we look at this, what are some things that jump out at you after looking at this graph?
There's consistently more people who got it right than who got it wrong.
Yeah, overall, the red bars are all taller for each group. That's one thing I'd really hope that we see. There's something else I hope we see.
When they were arranged in the right order, way more people got it right.
Yeah, this disparity is way huge compared to the other two disparities. Does that make sense? Okay, and that's a really important idea. Sorry, guys, that's my phone. I had it turned on for the weekend and forgot to turn it off. If that helps, it's Carrie texting me.
Like it was excusable then.
What do you guys think about a double bar graph? And if I had if it was a 3x3 table, we could make a triple bar graph and so on and so forth. Okay, so these can be useful. We could have just as easily had done the proportion of each one for each group. That would have been fine too. Okay, the next one's my favorite statistical graph for categorical variables by far my favorite. It's called a segmented bar graph. Some of you have probably seen it before. I don't know if Mrs. Downer now does this in geometry and if that would cover some of you. I know she and I have talked about her including this, but it's a beautiful graph. And to be honest, pretty easy to draw. So on my x-axis, I'm going to have title, which I keep misspelling. On my y-axis, I'm going to have the word proportion. And my y-axis is going to go up to 1. It's going to start at 0.1, 0.2, 0.3, and I'm just going to kind of count up. And each group is going to get a bar that goes all the way into 1. All right. So right now, is this a very informative graph? No. So what we're going to do here is we're going to cut each of these bars into segments, the percent correct and the percent not correct. Does this make sense? So for guys looking at that table up top, if I said for the Nate and AJ group, what was the percent correct? What would you say? So you're going to do 13 out of 17 and you get 0.76. So I'm going to cut that segment at approximately 76%. And that's the percent I'm going to do that red for correct. I'm using the same key for all of the graphs today, y'all. Is this okay? And then we do the same thing for the AJ Nate group. I think that was 53%.
Yeah.
And then 59-ish. What are the pros and cons of this graph, y'all?
We don't know how large each sample is.
Yeah, if I look at just this, it doesn't really communicate how large each sample size was. It does, however, show each group individually, so you can kind of see those differences amongst the groups a little bit more. I think these ones are really good for seeing relationships amongst variables, and when I say that, I mean like differences amongst groups, okay? But if our groups are totally different sizes, like really far away from each other, this graph can tend to be, could be misread, okay? All right, so we have one more. It's called a mosaic plot. This is probably the one you're going to be least likely to be asked about, say, on the AP exam. It is relatively new to the AP curriculum, though. At this point, it's like 2 or 3 years in, since they changed their curriculum up a little bit. Okay? Now, the mosaic plot is very, very, very similar to this segmented bar graph. Okay? But what it does is it takes into consideration that all groups are not the same size. So my y-axis is going to look identical to the one above. And my x-axis is also going to be put out this way. So it's also going to have percentages on it. So let me give myself some room here. Folks, help me out. What percent of the respondents were in the Nate/AJ group? What would we do?
The total responses?
We would do 17 out of 56, yeah? And we get about 30%, yeah?
Yeah.
Okay, so the Nate, then AJ group is going to be a bar that is 30% wide. Okay? And then likewise, since they're the same group size, I can say the AJ Nate group is also 0.30. So it's also going to be 0.3 wide. And then the boys is going to be roughly 40%, so it's going to be 0.4 wide. So it's slightly wider, communicating that that group was a larger group. Okay? So what we like about this mosaic plot, because Nico had just said one of the flaws is it doesn't account for the different sizes in the groups. This one does. Does this make sense? And then the height of each of these, like where we cut these off for the correct and incorrect, are the exact same ones that we used up here. We good? So, let's see. This one will be at 76%, then 53%, then 59%. Now, here's what I'll tell you. The probability of you having to draw a mosaic plot is very, very, very small. If I had to guess how you would come across a mosaic plot like this, it would be a one-off multiple choice question. Okay. So far, coming up with the graphs, how we doing? And honestly, the only one I could envision you guys having to draw on the AP exam is the segmented bar graph, and even that seems very unlikely. Okay. The bigger piece is these graphs, much like you guys, did you guys have to draw a histogram on the most recent test? You didn't have to draw one. Did I give you a couple that you had to like do something with?
Mm-hmm.
Right? So the graphs tend to be a stimulus type where they will help tell a story of a free response question or a multiple choice question, and you have to make sense of it. Okay? All right.